What's up, guys? All right, we're back at it. I didn't even need to restart my software. All I needed to do was change some settings in my Google Chrome. That seemed to do the trick. So that's definitely really annoying, but I mean, hey, at least we get started, even though it took 40 minutes, right? Anyways, just a quick recap. The last thing we did, for those of y'all that were watching, is we created a little impossible game-ish type game, right? Um, and we did in a day. So that was cool, definitely cool. I'm very happy about that. I'll go ahead and run around as a refresher, get myself back into it since I had to restart everything. Um, but yeah, guys, while I'm doing that, for those of you guys watching across whatever platform you're on, uh, if you want to follow along, we're still at the very beginning of our course. You know what I mean? We're on section 3, so still very beginner, even though making that last game we did was a pretty big help in terms of just understanding what we're gonna do. But yeah, now we're gonna do a rocket type game, like a Flappy Bird almost, right? Which looks super cool. I'm very excited. It looks a little more advanced. This is the game we made last time. Just a little simple, little obstacle course game, and it's not like I'm gonna work on it more. I'm happy with it, nice and simple. Not really gonna do anything with this project. As you can see, it's doing exactly like. Oh, I messed that up. Okay, that's fine. Oh, I did it effortlessly before I had to restart the stream. You guys believe me, right? Nice. Okay. Oh, that's 2. And that's it, guys. That's the game we made. Bam. It's always better than doing nothing, right? So that's where we're at. So the next game we're gonna make is gonna be a rocket game, like I said, and we got it working. It's actually displaying it. So it's enough of my yapping. Let's jump right in.
Bumping into the walls, and when we get to the end. Welcome to the next section of the course. This is Project Boost. It's been a crowd favorite for quite some time. It's all about a rocket ship that we rotate and we push with, give it some force to move in a particular direction. We've got to avoid bumping into the walls, and when we get to the end, when we get to the platform, then we're going to trigger that we go to the next scene. We load the new level. So we're going to be dealing with
Nice.
loading of
Okay.
scenes or levels, as we can call them.
That's
We're going to be
lit.
dealing with the fact the player
I'm
can
excited for
die and have
that.
to restart. And we're also dealing with a lot of new concepts from a programming point of view, building upon what we did in the last section and getting more complex and richer understanding of how these things work. Still with a fairly simple game, but the more we practice and the more we work on these concepts, the more it's going to sink in and the more powerful we become as game developers and programmers. So let's dive in and start Project
Nice.
Boost.
I'm hyped for that. All right. I started this last time, but I decided to restart the whole thing. The thing is, I did this like last year in August-ish, and I got like a quarter of the way through this specific section, and then I kind of stopped to do some other things since there's some other things I wanted to take serious, but I'm back at it, and I'm super excited. We did the whole section yesterday in one day. I unfortunately have to wake up for work. Super sad story, but I want to get at least through 1/3 of it. I think we could do that, or at least up to where I stopped, right? I think that would be a good check mark. So let me just figure out how to get this video to reload. What the hell? So again, guys, if you want to follow along, download Unity and VS Code really quickly. Um, I paid for the course. You guys could just watch it for free and follow along with what I'm doing, and I'll break down all
Now,
the
we've
coding
got our
prospects and
rocket
stuff.
In this lecture, we're talking about the game design for this project we're working on, and as always, I like to start any project with a little sketch, a game screen sketch of how the game's going to look, so we can get our core features figured out. We've got our rocket, obviously, and our rocket needs to fly from A to B, so we're going to need some sort of mechanism that says, here's where you start, some mechanism that says, here's where you end, so that you can complete the level. And of course, we need a way to control our player, and I think something as simple as saying steering left and steering right and boosting. So boost will make you go directly forward, and then left and right will rotate the rocket, so we can rotate it, and I think that'll be a really cool form of movement. If we did a movement where you just simply push right on the keyboard and your thing moved right and then down, it moved down, it'd be too easy. You're just like bing, bing, boom, 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 and you're all done. So this way we're adding some complexity with controls, making it a little bit tricky for the player, giving some skill of how they have to rotate the rocket and then boost. And then we'll have some gravity, which is going to be adding force downwards so that the rocket is constantly trying to crash into the ground. You're constantly trying to push it up so it doesn't crash into the ground. And then also I think we'll add some moving obstacles to add a little bit of different flavor and interesting things to avoid. There's a lot we can do with that. You make one sort of moving obstacle and you can recreate that and change the size and the speed and the positioning to get a whole lot of variety for the player. So there's our game screen. I also like to talk about what's the player experience we're creating. For me, it's going to be precision and skillful. I want the player to feel skillful. So it's going to be a little bit slower, a little bit more careful. It's not frantic. It's not just mash the buttons. There's a skillful element to it. The core mechanic, I've already talked about that, but it's good for us just to recap these things. Skillfully fly your spaceship and avoid environmental hazards. As simple as that. Just avoid bumping into stuff. The core game loop, get from A to B in a particular level to complete that level, and then you'll progress on to the next level. When you've gone through all the levels, then we'll loop back to the start. As per this flow diagram I've got here, you start off on level 1. When you complete level 1, then you go on to level 2. When you complete, so if succeed on level 2, then you go all the way through to our final level. Once you complete the final level, then you would loop back to level 1. And previous iterations of this game, I've had if you die, you go all the way back to level 1, but I found that's no fun, because it's very, you end up doing level 1 over and over and over, and you might get to level 4 and then die and back to level 1. So I think it's better to say if you die on level 1, you stay on level 1. If you die on level 2, then you stay on level 2. And it could be in the future we implement some sort of life mechanic so that, you die 3 or 4 or 5 times and then the whole game resets. But for now, we're just going to keep it very simple, no lives, just have it that you can progress through the whole game so long as you can actually make it through that level.
3 levels.
And then just touching on the game theme, which is the story and the
that means I
visuals
might
and the
be able
whole
to make
flavor
one
for what it is that we're
by the
creating.
end of the night.
We're not going to spend a lot of time on this because this is not an art course after all. It's more of a programming course. But I want to just cover the fact that who are we? What are we doing? Where are we trying to get to? And our player is an experimental early generation spacecraft. I say early generation because it's very basic. It can't do much. It can't shoot. It can't even steer very well. So I'm trying to give that feeling in the story and the visuals. We're on some unknown planet we're trying to escape. There's not really any rules, so I didn't want to give too much flavor to this, mostly because I want you to be able to create whatever sort of game you want, have what sort of theme or what sort of story, who's the player, what sort of visuals and graphics you're using. I want you to be able to do that without being distracted by me too much. So I've done a fairly plain implementation, but I do have a challenge on that, which is to come up with a theme. Think of a central theme for your game. Decide on a starting name for your game. Mine's going to be called Project Boost. I don't know why we've just had that name for a while. It seems pretty good.
Or Flappy Rocket. I'll call it Flappy Rocket.
So there we go. And to share what you come up with for your theme with the community. So when I say share your theme, it's where is it located, who is the player, and what's it going to look like. If you have some sort of graphics you've come up with already, or you've got some assets from the asset store, then please do share that with us. And if you've just got an idea, share that with us as well. Find the link against this lecture and you can share with the community. So there's your challenge.
Nice.
This is the project we're going to be making. Let's dive in and talk a little bit more about it.
The central theme is what, a rocket flying. I'm gonna call it Flappy Rocket or Flappy Boost.
In this lecture, we're going to talk a little bit about
The
game
Flappy
design
Rocket,
and
Flappy
how to make
Rocket.
decisions on your indie game project. Specifically, we're talking about onion design. Now, there's some common development questions that I see all the time, particularly with people who are starting out making games. Things like, what features should I include in my game? And Where should I start my development? What thing do I start with? What are my priorities? What if I run out of time or money, if that might be the case? And when should I stop? When is my game finished or good enough? Well, for me, I keep coming back to this philosophy of onion design, which is basically saying identify your single most important feature in your game. What's the thing that you have to have and you can't make the game without? And then figure out what's the second most important feature, and then what's the third most important feature. And you can see each of these is layering on top of the onion. So right in the middle of your onion, you have the core, the thing you have to have, and then layer and layer and layer. You might get to the point where you have enough time and money and interest to have 10 of these layers on your onion, but at any point in time, if you run out of time, you say, well, I've got in the top 3 features, so now is a good time to start. The thing here is each time you my important Project Boost, we could have fuel, we could have shooting, we could have power-ups. There's a lot of things that we have in here that we'd say that would be cool. And I'm sure you could sit down and come up with another 5 cool features that you could put into this type of game, because if you've thought about games, if you're interested in games, you've got a lot of ideas. But the reality is we just can't implement everything. So I've got a challenge for you. It's to sketch out our onion design. Specifically, what do you believe is the single most important feature of the game that we're working on, that I told you in the last video what the game design was for this game? What do you think is the most important thing we absolutely have to have if we don't have anything else? It's the third most important feature. Just a feature. Power-ups is a feature. Getting from A to B and having it start a new level is a feature. Moving obstacles is a feature.
Second is the
obstacle.
obstacle.
Is a feature. So this is what I mean by feature. So important things for our particular. Let me tell you what I think. Moving, or we can call it flying, but it's movement of the player, and nearly always really critically funny, right? And die somehow.
Yeah, well, collision. That's what I
we
said.
need to have the player feel like they're getting through something. So if we
I
were to
feel like there's
have
not
enough
really a
time,
right or
I
wrong
might say
for
that,
this. It's
for
kind of
example, a fuel
subjective.
mechanic
No,
might be no
it's not
means your
factual,
project lecture is if de-risk the most the be with frame of mind.
Okay, I'll take it. It's fine. Unity units. Alright. Number 4. We're already
in this video,
caught up
we're going to start our project and get a couple of the
video.
basic building blocks in place.
Okay.
Let's start our project by creating a new project. From within Unity Hub, click on the new button. We want to make sure we're on 3D, and I'm going to call mine Project Boost. I'll put a space in there for mine, but because I've already created it, it gets a little bit upset. So just for illustrative purposes, I'll remove this space. Location, Repos, Unity 3D, and then click the Create button. As I mentioned, I just created mine before to make sure everything's working fine. So I'm going to open mine up by clicking on Project Boost. Give it a moment to load, or if you're creating it, give it a moment to create it, and then we'll be into our project. You can see in here we've got our standard kind of nothing world, nothing's going on. Up in the top right hand corner we've got the directions, and it's important that we pay attention to that so that when you're setting up your world, it's set up in the same way as mine. For example, I'm going to have my rocket going from left to right, which means that the x-axis is going to be the direction I'm wanting to kind of go from negative x all the way over to positive x. If I'd started my world and rotated it like that, then you can see my widget, it's going to be from left to right would be Z. So I'd be really confused if I was putting these values into my code where I wanted X to increase and my rocket's going way off into the distance because I thought I had it rotated and set up a different way. So just pay attention to that. We're going about creating our world. I'm looking at with Z is into the world and Y is up and X is from left to right. What are we creating? Well, we're just going to very quickly create a ground, going to create a launch pad, a rocket to go on the launch pad, and a landing pad. No functionality on these things in this lecture just yet, but we're getting the framework so we can start to add things to it. And I'm going to keep it very simple, just one simple shape or primitive for each of these things, and later on we can get a little bit more complex. In particular with a rocket, I'll just put in a stretched cube for now, and then later on I might put in a nose cone and some boosters and a few other nifty things, but I just want to get things working before I put too much time into finessing how things look with the functionality. So let's start that together. We'll do the ground together, and then I'll give you a challenge to go ahead and do some more yourself. Just a reminder here, plus X is to the right, plus Y is up, plus Z is forward. So I'm going to right click and create a 3D object, which will be a cube. And you can see the cube is placed right in the middle of my screen, in my scene view. However, that means the position is not exactly in the center of my world, and I'd like it to be in the center of my world. So I know that my game is playing around the origin being the 0, 0, 0 point. So if I right-click on my transform, reset, this cube will now be right in the origin, so that the midpoint of my world. It's very handy to know that. It's not critical to do that. You could have your game played way off over there if you wanted to, but this way I have some consistency with my values, so I know if I'm heading in the positive X from this point, it's going to be heading to the right of the origin. If I was to set my whole world up so it was way down here, then it might be starting at, let me just drag the dude down there for you, it might be starting at 49, so if I'm going from 49 or back to 42, it's not as clear that I'm going in the right is positive and left is negative. So once again, just right click and then reset transform. It's off the screen, but I'm clicked on it, so I can hit F, and that will zero in onto my cube. And I know it's right in the origin. Now we've talked a little bit about units, but
I know how
not
to do
a lot.
this
You
stuff.
can see
That's
here
why
that
I'm
the
not pausing
scale
it,
of
but
my
I wanna
object
see what
is
he does.
1, 1, 1. That means that we are one unity unit in our X value, one unity unit in Y, and one unity
thing
unit in
is
Z. What is a
still
unity
opening up.
unit,
Come
you
on,
might
bro.
ask? Is it a meter, or is it a centimeter, or is it a kilometer, or is it a yard, is it any other unit such as that? Well, it's just one. That's what it is. So it's a generic kind of unit. We can say, for our purposes, well, let's call it a meter in our mind. Then we've got a point of comparison from the real world to what we're doing in the Unity world. But Unity doesn't care whether it's a meter or centimeter. It just knows that it's one. So that's often the basis for what we are using in our game. I tend to try to look in terms of the size of the player. So if you're running around in the world with a humanoid character, you might have your character be, for example, 1.8 or even just 2 to make it convenient to say this is roughly a 2 meter tall hero. So I'm not sure exactly how tall the rocket will be yet, probably 3 or maybe 5. It's not to scale as a full NASA rocket would be, but it gives us some perspective of if my rocket is 5, then I should probably make my launch pad 2, for example. Now, how wide do we want our world? If you remember, we've got a couple of ways to scale. We can mouse over the X and drag like that. We can type straight into the field just here. I could type in 20, for example, or I could click on my scale tool or the corresponding letter, which is R, to drag and scale. So as I scale, it increases the scale that's in the value just here. I think I'll make, for now, let's make it 100, just so it's nice and huge, taking up plenty of space for our ground. We might not use all of it, but that's not too bad for the moment. And then how wide do we want it? Well, we're going to have our camera position in front of the player. I don't really want them to look like they're kind of flying along a balance beam, so let's give it a bit more depth. Depth would be, in this instance, on the blue axis, and the blue axis is the Z axis. Let's give it, say, 20. To make a little world there, and then a little bit of fatness as well, a little bit of height to it. So once again, you're not thinking that you're running around just on this weird floating platform in the sky. We'll make it 30. Now, because I've made it 30, you can see that it's grown. It's scaled the cube equally upwards, or positive on the Y, and negative on the Y. So now the top of my object is way above where the midpoint, where the origin of the world is. And I think for now I'd like to have the ground be at the origin. So I need to lower my entire cube down by a certain amount. How much do you think we need to lower it down so the top of my cube is at the origin height? Well, if we have 30 as our entire height, or our Y value for our object, then we would need to lower it down half of that to get it to the 0 point. So I'll put in minus 15 in position. Now the top of my ground is right at the origin level. You can kind of see that by our grid lines kind of sitting on top of it. It'll be more clear when we add another object, and it'll be sitting right on top of that at the origin level. So I made that just minus 15 on the Y axis. The other thing I'll do here now is I'll give myself a little bit of color for the ground. So in the assets folder, I'll right click and create a material. Material I'll rename to be ground. Drag the material over the top of my object. Hasn't done anything yet, but while I've clicked on my material, I can jump over to the albedo, make it groundish kind of color, which is probably going to be a brown sort of thing. Okay, there we go. Brown for now. We can change it anytime in the future, but we've got ourselves a little bit of ground. Brown ground. Okay, time for a challenge, which is to build our starting pieces. Create the items from just one primitive each. So I just used one primitive, which was a cube in this instance, for my ground. Later we'll make things more complex, but I just want to get us going with this. Create the ground, the launch pad, the landing pad, and the rocket. So take on that challenge, give them colors if you so desire, and I'll see you back here when you're done.
Alright, so create the items for just one primitive later. Okay, ground. Okay, that's cool. Ground. We did that. Launch pad, landing pad. Okay. I guess we'll do a cube for the landing pad. I'll probably, what I'll do is this. I'll do like a 3.5. 3.5. 3.5. Go 1. I'll not even know 1. I'll do a 0.25. Yeah, that's good. And then I'll duplicate it. And now to the left, to the right. Is it touching it though? It is. All right, cool. That's good. And oops. That's good. And then I guess let me move it a little. Alright. I'm gonna do negative 45. I'll do regular 45 here. And then I'll make a color for the platforms. What color should I make it, chat? What color should I make it? Red, blue? Like I'll do blue. I'll do blue. Blue is cool. Alright, create material. Blue. I like that, like an aquish blue. I like that. Yeah, I like that. A little darker. Nah, like right there. Yeah, I like that. Alright, I'll just go ahead and add it to both. And then I'll rename it Start Pad. Oh wait, no, Launch Pad. Launch Pad. And then Landing Pad. Maybe he's gonna make it a different color, but whatever. Then I'll make this call this ground. And then we'll make one more, create 3D object, cube, and I will make this tall. I'll make it 5 tall. I want it to be tall. It'll make it harder for us to use. And I'm gonna leave this white. I'm actually gonna leave this white. I like that. If I could, I'd add little windows, but I'm fine with this. My thing is, how do I make it so that there's gravity on it? Well, I guess I do have to turn it on with a rigid body, right? I'm gonna go ahead and do that before it even tells me. Because I think that's what we're gonna do. Use gravity, yeah. Okay, let's see.
Okay, let's finish off the last couple of things here. I want to be really clear on this. If your size keyboard, move to the left a little bit, 3 on the Z as well as the X, and then probably 0.5 to have it a little bit flatter. That's okay if it's underground like that, but I'd rather have it sitting on top. So how much do I need to move this up? Well, I'll just drag it. I don't need to have it exact. It's okay if it's a little bit underground, but you can see that I've had to drag it up around about half of what its height is. So if the height is 0.5, I had to drag it up 0.23 to get the whole thing above the ground plane. The top of the ground plane, if you remember, is at the 0 point. Okay, let's give it a color. So right click, create material, call this launch pad, drag it onto the launch pad, change the color, we'll make it a bluey kind of color to say this is where we start. Again, if yours is not blue, not a problem, that's fantastic. Have it look different to mine so that you're thinking about it differently, using a different part of your brain to process what's going on, not just copying. Nice. And one habit I want you to get into right from the start here is that we prefab everything. So I'm going to grab ground, just drag it into my assets folder. We'll tidy this up shortly and give it some other directories and folders in here, but for now we'll just be a little bit quick while we're setting things up. And the launchpad, grab that, drag that down as well. Why do we prefab everything? Well, if we want to use these in other levels, it's prefabbed already. If I want to make a change and roll it out across all those things, it's there. If I want to have multiple versions of this, then I can do that as well. It's great to prefab everything. It also means that these are being saved directly to the disk and not just being saved as part of my scene asset, which is a good thing to do as well. Okay, so I've got a launchpad. I'm going to click on that, Control D to duplicate, drag it on over. It's going to be essentially the same thing, but different name and different color, so I will rename it to be... What do I call this? Landing pad. There we go. I've already forgotten. Landing pad. That makes sense. The place that you land. We will duplicate the material as well, just to skip a step a little bit, and I will change that to be called landing pad.
Nice.
Make sure that we drag landing pad onto the landing pad. We'll change the color there to be sort of a green color to say this is where you finish, I think. Now, the last step in all of this is to create a rocket, so I will right-click 3D object. Once again, I'll create a cube, just to have it really basic. Drag it on over. This one I'm going to manually position. Now, it looks a little bit fat, so I'm going to skinny it up. So on the X scale, 0.5. On the Y scale, 0.5. And on the... Sorry, that was on the Z scale. And on the Y scale, I'm going to make this 3 for now. I will definitely be changing how this looks later on. But for the moment, that's what I'm going for. Actually, that's a little bit taller than I'd like. So let's make it 2. Okay, that's good for now. Just pop it on the launch pad. Actually, I don't need to have my rocket zeroed at the 000 point, but I do want to have it zeroed on the Z axis. I don't want it to be a little bit further back or a little bit further forward. I want it to be right in the 0 point. So simply just go into my position of Z, put that at 0, and I know that it's definitely at 0. So as we're flying along, I'm going to have it constrained throughout the whole game to be at 0 on the Z axis. Okay, and so I urge you, whenever you're starting a new project, go through this process, just quickly slap down some primitives, play around with it, and then start adding some code. Get a game that feels good. When you've just got a cube flying to another cube, then you know, I've got a game on my hands here. Then you can make it look prettier and put in more functionality. But as a starting point, you want to be up and running with just the basic building blocks. It's a good way to do it. And of course, before I forget, we'll rename our cube to be Rocket, and we'll drag our rocket down to become prefabbed, and we'll give it a color. So grab the launch pad, duplicate that. I will rename this to be called Rocket. Drag the rocket onto the rocket. Clicking on the rocket material, we'll change this to a... I'm not even sure, maybe an orange. Nice bright orange. Actually, more to the yellow direction.
I like 5.
I want to have everything pop and stand out, not blend into the ground. And the last thing I'm going to do here is just save everything up. So that will save my scene, the scene we're currently in, which is called Sample Scene. And obviously, Sample Scene's the only thing we're doing in our project at the moment. So that's a way of saving the whole project. But you don't save the project, you save each scene that you're working on as you go along. And looking within our Scenes directory, we have something called Sample Scene. I'm going to rename that by hitting F2 or clicking on it slowly a couple of times and just call it Sandbox.
Wait, what do you do? What do you do? I missed that.
It's the only thing we're doing in our project at the moment, so that's a way of saving the whole project. But you don't save the project, you save each scene that you're working on as you go along. And looking within our Scenes directory, we have something called Sample Scene. I'm going to rename that by hitting F2 or clicking on it slowly a couple of times and just call it Sandbox. This is the place where we'll be playing around. And then because the following scenes have been changed, it wants us to reload the scene. Not a problem. We'll click on Reload. And then it's exactly the same, but now we know that it is called Sandbox. And you can see there's still a file in here called samplescene.lighting. Don't worry about that for now. When we bake our lighting, or when it auto-generates lighting, then it will give lighting for us. You might also see I've got this little cog here. Sometimes you'll see an exclamation mark. If you don't have that, not a problem. It's just because of the way this particular version of Unity has wanted to set things up for me to have some version control indicators in there. So don't worry if you don't see the symbols. Don't worry if they're different to mine. All you need to look for is the name and the extension, for example, .unity, even if the icon is a little bit different to what I'm seeing here. Unity seems to change these things around.
Alright, next, introducing classes. Alright guys, I already know what classes are. Yeah, this is all just an explanation. Yeah, classes are literally just like the blueprint for a specific like functionality. Like if let's say I made a class, that is kind of hard to explain. But even if he was to explain it, like a class, it's just a blueprint for like whatever functionality you're trying to create. If I make a class, let's say. The thing is just that classes can define an object, but they could also define methods that are like related. So like let's say I wanted to make a class for movement, right? Yeah, there you go, movement. And I would assign that class, I would attach it to Rocket, right? And in that class there would be a bunch of methods that would define how it moves. I don't know if he's gonna make a. Well, I mean, yeah, actually, every script is a class, right? Like that we've done so far, at least. So yeah, I guess you would just drop it on, but you could add multiple classes to an object, and I guess that's
Call
what he's
this
gonna go
method
for. But yeah, I'm not gonna watch that, guys. I already know what that is. Even if you guys were
In
to
this
watch, I
video, we're
don't think
starting
you
the
would
process
understand
of
it.
binding
Programming is hard
key
to
presses
grasp.
to actions within our game just by printing out to the console if we're pushing space to thrust or rotating right or rotating left. So let's get started. Let's start by doing a quick bit of organization. I'm going to create some folders and then put my assets into those. So right click, create a folder. What should we call this? This one can be for our materials. So call it materials. Let's create all our folders first of all. Right click, create folder. We'll call this prefabs. And what else do we have? We've got a script. So right click, create folder, and we'll call this scripts. And then click on ground. That's material, 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 material. These round balls here are materials. So I'm just control clicking on those, or command clicking if on the Mac. Drag that over into materials.
Got our prefabs.
And then ground, control click, launch pad and rocket.
Oh, he
prefabs.
did make.
Drop that into
He did make a class. Okay.
True or
That's
false,
annoying.
whether
It's okay. We can find it. Okay.
not, we have just sure that our script in a namespace. So this whole system is a way of organizing our code. Let's just have a little bit of a look at the class that we created. We can see here that we've got class as a keyword right in the middle, and then movement is the name of our class. And as is the case in Unity, we need to make sure that our script, so this is the document, this is the file, is our movement file, .cs is a type of file, and contained within that file is our class. We have in here the class of movement.
There you go.
I tend to use the two interchangeably. I'll be talking about the movement class and the movement script, because more often than not, we have just one class per script. You can see we've got the public keyword. We're going to talk about public versus private a lot more later on in this section. Have these you have created for us. And you can see...
Yeah, guys, if you guys really want to see his full explanation for that, buy the course. But honestly, you can figure that out like with Copilot.
Double click on that.
If you want to know what a class is, go on Copilot and ask Copilot, hey Copilot, what's a class in C#? Ask it what a class is, and also add, explain it to me like I'm 5 years old, or explain it to me like I'm an idiot, or like I'm just dumb as hell. And Copilot does a great job of explaining it in simple terms. That's how I grasp everything, easily for me personally. My little personal hack. So if you want to know, there. But yeah, guys, I don't want to spend time
triple
watching
click,
that.
quadruple click. There we go. Clicked it eventually, and open up movement. Let's start by creating a method in update that I'm going to call process input, capital P, capital I, and then parentheses and semicolon. That means that we're calling a method called process input. Well, we haven't created that method yet, so let's go ahead and create it. So give ourselves a couple of lines. For me on line 20,
not usually
tab
how
in
it's
once.
typed.
I'll create process input, and then parentheses. Now, we always need to give our methods a return type, so at the start, give myself a space. We don't need to have anything returned, so we'll have return type of void. Back down to the end, give myself a space, add in our curly braces so that we can put in our statements or our code block. And so what do we want to do here? Well, we want to process input. We talked about this in the previous lecture, that we have a class we can access called input. We scroll down to the methods. We saw that there's a couple in here that are candidates. Get key and get key down often cause a little bit of confusion. What's the difference between the two? Well, get key down returns true during the one frame, the single frame, the user starts pressing down the key identified by the name. So if you want to tap, if you want to say, did the player push the button, then get key down is good. If you read for get key as a method, returns true while the user holds down the key identified by name. So if we want to know, are you holding down, so are you holding down space so that you keep pushing your rocket jet? If you hold down A, so you keep rotating to the left, that is what we want to be getting at. So get key, we'll click on that. What I want to draw your attention to here briefly is the fact that there's a couple of ways that you can add your information in here. So first of all, we can see that we have a public static bool get key with string name as the parameter, or as the information that we need to be putting into this. And if we scroll down underneath this, you'll see, hang on a minute, there's another one where it's public static bool get key, key code key. And you'll see the example in here, input.getKey, and then we have in the parentheses keycode dot up arrow, whereas in the previous example we have input.getKey, and then in parentheses we have the quotation marks and up. What's going on here? Why are they different? Well, this is a nifty way of Unity saying that we will accept either of these two approaches to say what particular key is pressed.
Okay, I don't care. Let's just get to it. What is it?
I, because classes are going to have a capital
I'm not going to memorize these
front.
things.
You can see when we have movement, we have capital
chat. For those of y'all listening, look, a lot of people, like people that might not be in programming, you might think that like these programmers know like every method, like they just memorize it. Like, no, bro. There's way too many methods and classes and functionality. Even the best of programmers, like they don't memorize that shit. Like they just know, they might know how to go about debugging. Like they might have ran into errors before, so they know where to look to make fixes. But as for like, do they remember all these methods and all these? No, they don't. They don't. So I don't care about all that. Like, cool. Thanks for explaining it. But whatever you teach me, I'll just learn it that way. I don't need to know every way to do it. So that's my explanation for that.
Get key.
Input.
Methods also have a capital letter. It's variables that have the lowercase at the start of the word. So get key, parentheses, and you can see what has popped up for me is a little bit of information that Visual Studio Code, clever as it is showing me. It says 1 out of 2. These are the two different signatures, and I can cycle through these if I don't accidentally click in the wrong spot, which is good. I didn't do that on purpose, but I was ready for that. If you lose that, if you're like, where did that bit of information go? When you mouse down over here, we're not seeing that anymore. If you hit Control, Shift, and Space at the same time, I'm guessing it's Command, Shift, and Space on the Mac, this will show us the signature options. And now if I hit the arrow, or you can hit up or down on your keyboard, which is what I'm doing now. It's a little bit easier. That's showing us the two different signatures, the two different options. One is with string and one is with key code. So it's just, I'm just going to show you how the string would look. For example, if I put in here space with a capital S, space, that's how it would look if we're using the string reference. Now, where I could have visual space, it's like, aha, you want to be using space here. If I hit tab at this point, it'll auto-complete and put in what it was that I was looking for all along. Okay, so we've played around with input and we've got get key, but it's not yet doing anything meaningful. We need to have an if statement in here, because it was saying if you push the space bar, then something happens. So if you remember in our previous section, if I put a space, you don't have to put a space, and we put parentheses to wrap our condition in here. So we're saying if this particular thing returns as true, then what are we going to do? Well, we need to give ourselves a line, put in our curly braces for our code block. I'm just going to say debug.log, and then we'll print out something like pressed space. Let's add a dash here and say thrusting. Let's save that up, back over into Unity. Now, this is not going to do anything. We're not going to have anything appear in our console if we play the game. So a little mini challenge for you. What do we need to do in order to have that little bit of code that we just created actually work when we play the game?
You have to drag it to the rocket, and then when you hit space,
that was me pausing to give you time to yell at the screen. We need to attach our script to a game object.
Yeah, our rocket. And then, okay.
Selected.
So every time you press space, it prints it.
And I'll get you as
get to the juice. Get to the meat.
Rotate left when we push.
Get to the meat and potatoes.
Rotate right.
Am I right, chat?
And as a bonus, statement will execute. Now we'll put in our semicolons just as a reminder. Whenever we have our statement we're executing, we need to have our semicolon. And the challenge is to finish our code. Replace the somethings with actual code. When we push A, then print rotate left. When we push D, then print rotate right. And as a bonus, for bonus points, identify the bug or the issue with our logic, which means it won't actually work properly or the way that we want it to. So there's one little thing in there that we haven't quite done, but see if you can identify what that is as well. So pause the video, take on that challenge. I'll see you back here when you're done.
Input.
We've got our if statements. I'm going to add in
we have to make a variable. He wants us to make a variable.
And what key do we want to press? Well, key code.
What the value being passed and get key is. That's my guess. Let's see.
A. What happens when we push A? Well, the do something is going to be debug.
Okay.
Dot log.
Guys, print statements. No.
Number stop.
You know what? I have an app. I have an app that will teach you C#, and you can get through it so quick. Like, it won't teach you how to like go through frameworks and like a lot of the more complicated stuff, but it'll at least teach you like variables and you know, data types and like just the basic stuff like that. That's really all you need to get through a course like this. Remind me at the end of the chat, at the end of the stream chat, I'll show you guys. It's super good. It's super cool. It's just like a little app that you go through, almost like a little quiz thing. It's really dope. I used Mimo to learn JavaScript, like to really refine my JavaScript understanding, and it's been super helpful. And I think you guys will like the chat. This cat keeps biting me.
You're pushing space, that's good. If you're pushing A, that's fine as well. What we'll add in here is an else in front of the if. So we're saying else if we can rotate to the right. And this will apply for these two statements just here. We've got an if, and then the very next condition.
I'll do it just to memorize it, but I don't want to.
If we're not satisfying the condition just above, then we can do this particular condition. And because this is a little bit messy, I think now, having our thrust and our rotate in the same spot, I'm going to break this out into be separate methods so it's super, super clear. Okay, so there's going to be a little bit of renaming here we'll do. I want you to click on process input, right click, and then rename symbol, or F2 on the keyboard. From here, I'm going to rename this to be process thrust,
okay.
And then hit enter. And that will change both of my process inputs into process thrust. Now let's add a new method, which is going to be called process
void process
rotation, parentheses, semicolon, and underneath process thrust, I will create a new line, space, void process rotation,
I'm so close.
parentheses,
I can taste
and then our code block. And what do we need to put in process rotation? Well, I'm going to highlight my second two conditional board. Keep making sense, clean up any spacing. And I think that's a bit cleaner now because we're saying if you're pushing then rotate left, a little bit better. In other words, given priority.
Hey chat, I'm gonna make sure to say meat and potatoes.
Left will overtake. Left will be the dominant direction, which I think's fine because we don't want the player to be pushing both directions.
Alright, cool. Hey, we're already almost caught up to like where I was. I didn't go too far, damn.
In this video, we're starting the process of making our rocket fly by when we push down space, it flies up in the air. Okay, let's get cracking. Let's start with a little micro challenge for you here. I want my rocket to be able to fly through the air and use the Unity physics system so that things like gravity apply to it. So what do I need to do first in order for this rocket to be able to fly? Well, the first thing we need to do is add a rigid body. A rigid body allows objects to have physics applied to them. So I'm just going to close up a couple of things in here just so I've got a bit more space. There we go. Movement, so just rolling these up. I'm going to add a component, type in rigid body.
Wait, hold the fuck up. Where'd my shit go?
You can see mass, drag, gravity, etc.
Where did all my shit go,
so a little test, I'll pop it up in the air, click on play, and boop, drops back down to the launch pad. Fantastic. Next, what we want to do...
Wait, hold up. Where'd my shit go? No way. No. Are you serious? Where'd my shit go? Yo. Huh? I don't... Come on, I was already there. Bro, there's no way. I just set everything up. Why is it doing this? Oh, you know what? I definitely like lost track or something. There it is, see? Oh wait, no. It's all gone. Why? Did I do something? Oh my gosh. I didn't do. I'm not gonna lose it. I'm not about to scream. I just hate being slowed down by shit like this. Like, if I'm gonna slow down, let it be my incompetence. I mean, I guess this kind of is my incompetence, but at least let it be like I can't figure out like code or something. Not where the fuck did everything go? You know what? You know what? This happened after I saved the sandbox. This happened after that. That's so annoying. That's so annoying. Why is it doing that? Why do it give me such stupid ass advice? Fucking dumbass advice. Why do I need to make it into a scene? Why didn't you do that? Why wasn't that the first thing you fucking did? Bro, this shit makes me so mad, bro. Reset. Like, bro. Oh, it won't even let me zoom in? Yo, what the fuck? That's not the ground I made. Position. Revert. Okay. Revert. Okay, I guess. Landing pad. Revert. Whatever. As long as it fucking sets up, man. I don't care. Wait, launch pad. I'm sorry, my oh. Position revert. Are we looking at the wrong side? Landing pad. Position revert. Rocket. Position. Okay, at least they made it easy. Fuck. Negative 45. Negative 45. Sure. Okay. Okay, whatever. Okay, I got back to where I was. I'm back at square one. Or at least got it set up to how I liked it. File, save. Okay, next time we're doing that first, cause what the fuck, man? All right, we're back. We're back at
Is
it. We're
when we
back
push
at it.
spacebar, we want to add force onto our rocket in
Yo,
the
I'm just
up
raging. All right,
direction,
chat.
but not just in
Damn.
the Y direction, because if we rotate our rocket, so we're flying along, we rotate that direction, now we want to be applying in, that's kind of like the X direction, isn't it? But it's all going to be relative to the rocket. I'll just undo that rotation. Relative to the rocket, basically we want it to thrust upwards relative to itself. Let's jump over into scripts, open up movement. And the first thing we need to do, because we're going to be applying force to our rocket through the rigid body, we need to get a reference in our class just here to the rigid body. So if you think you know how to do that, a little challenge for you here is grab a reference to our rigid body that we can use throughout our class.
I could just open up other scripts.
That was a bit of
but
a
I'm not
vague one.
going
If that
to.
didn't make sense, not a problem. We're going to start by
Something,
creating
get
a
property
variable. Now
or
this is a
something like
member
that, I don't
variable.
know.
What does that
Doesn't
mean?
matter.
It means it's available to everything in the class because I'm putting it within up at the top.
Stop
Is going to
yapping,
be what
do
I would
it
do
already.
is
Rigid
name it
body.
something
All
as
right, bet.
clear as possible. I would name this rigid body. If I hit tab on that, you can see that we've got a bit of a conflict. It's saying movement.rigidBody hides an inherited member. Basically what it's saying is this is already taken, so please use something else. Now we could add a capital B in here. I don't feel good about that either because you
Why?
can see rigid body at the class level is one word, so we don't have a
what?
capital on the B. So
It doesn't
I'm going to
matter.
break my convention a little bit and just call it RB. You'll see this used quite a lot
okay,
if you're looking at tutorials online. RB is kind of the shorthand for rigid body. Normally, I try to do more than just initials because later on, if it's buried within my code, I don't know what it is. RB is nearly always rigid body. So for this one instance, it's fine. If you're not comfortable with it, you could name it, say, my rigid body if you're more comfortable with that. I'll name it RB because I think you get it. I think you know what we're doing here. So this is a variable to which we can cache rigid body. How do we get rigid body? How do we store it in this variable? Well, in our start method, we get component and we need
That's
our
what it
angle
is.
braces.
Angle braces
What are
in
we
there, we
searching
put
for
the
here, or
rigid
what are we
body.
getting? Sorry, we're getting rigid body. Hitting tab each time you see me autocomplete there. And because we're calling a method, we need our parentheses and semicolon. So there we go. We're getting the rigid body component as the first thing we do in start, and we're storing it as RB. Well, we're not storing it just yet, are we? We need to add that as our storage. RB equals get component. So right at the start, RB is going to be getting the component of rigid body. That's us caching a reference to our component. So I've explained this in a reasonable amount of detail this time around. I'll go a lot quicker in the future when we're getting a reference to a component, now that we've done it once. Within here,
Bro
what can
yaps
we do
a
to
little too
apply
much,
force?
but I
Well,
get
know
it
the
for
answer
the
to this
beginners.
already, but if
So
we
I'm
didn't,
not-
we
I'm
can
not
have a
gonna
little
be
look
mad- I'm
around
not
and
mad
see
about it.
what are our options in here.
But
There's a lot
I
to
just-
scroll
for
through, so
me,
it'd take a bit of time, but
I don't like
you can have a
waiting.
look. Add explosion
RB
force, that
dot.
doesn't quite seem right. Add force, well, that seems pretty good, but I know what we want is add relative force. So let's click on add relative force, mouse over that, and you can see that we've got some information. Adds a force to the rigid body relative to its coordinate system. So it's relative force, as I was talking about before. If we're rotated this way, we still want to add the force relative to this particular object's coordinate system or its transform information. We don't want to be doing it just based upon the world space, or else all that's ever going to happen is just going to go up, up, up. Now, what actual force do we want to be adding? You can see we've got some overloads in here. We've got some different signatures.
Okay.
We cycle through those. You can see vector 3 force, comma, force mode. You can see we've got vector 3 force.
I don't know what those are. You
about
don't gotta go
coordinates.
through them.
So first of all, what we need to know is we're adding here, we get a bit more information, representation of 3D vectors and points. The
Vector
important thing to
3.
know is that when we're using a vector 3, it's not one single number, it's 3 numbers. 3 values, I should say. One for an X, one for a Y, and one for Z. The other thing I'll add about vectors is a vector is both direction and magnitude. So it's very different to position. Position is 6 minus 6.75. That's our position in the world. That's X. But that doesn't show us where we're going or how fast we should get there. And if we want to move our object like that, we need to know it's heading upwards. You can see Y is going up when we do that, and it's heading at a particular velocity or a particular speed, if you will. And a vector allows us to capture both of those pieces of information, not just how fast we're going, but also what direction we're going in. And obviously a vector 3 is going to have x, y, and z. If we're making a 2D game, it would be a vector 2, and we'd most likely just have x and y, depending upon which axes we're using. So 2D game, we just have the green one, which is y, and the red one, which is x. Unless we changed our game around, you can have it with the other axes, but convention says we would use x and y if it was a vector 2. You can check out our Unity 2D course for lots of other vector 2 type conversations, but in this course we're talking all about 3D, therefore vector 3s. So if I was to pop in here, add relative force 1, 1, 1, and then semicolon, we're saying to the rigid body, add relative force relative to the rigid body's position and rotation of 1 on the x, 1 on the y, and 1 on the z. Let's save that, see if it actually works. Click on play. Pop into game window, push on space, whoop, and it makes it fall over.
Yeah.
Now what I'm going to do here is just have a little bit of a play around. We'll change this back, but for now I think the mass is too heavy. Mass of 1 is just a unit, doesn't mean anything. Is it 1 kilogram? Is it 1 something or other? We don't know, it's just a 1. I'm going to put this down to 0.2 for the moment, just so we can illustrate until we get some more variables in here to modify the force. I'm going to put it to 0.2, click on play. And now when I hold down space, vroom, it flies off. 1 unit for each frame that we're playing on the X, 1 unit on the Y, and 1 unit on the Z. That's why it went off in that particular angle. Side note, while I'm here, I'm just going to move my main camera a little bit. Double click on main camera. It's not critical, we'll be doing more finessing later. I'm probably putting in a follow camera, I think, using the Cinemachine. But for now, I'll just get a little bit more view of my world so I can see when I'm playing around with my rocket. So back into our code, we added 1, 1, 1. What we could do instead of adding 1, 1, 1 is add, say, 0, 1, and 0. And that will make our rocket do what? Make it go 0 on X, 0 on Z, and 1 on Y, which is making it go straight up in the air. Let's click on play, just make sure that works. Okay, boop, 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 there we go, up in the air. We've got a rocket taking off, which is exactly what we want. Now, one of the interesting things within Unity is we've got some shorthand ways of writing particular things. So 0, 1, 0, there's another way we can write this, which is vector 3 dot up. Basically saying, make it go up. And once again, you can see that we've got a little bit of information here, shorthand for writing vector 3, 0, 1, 0. It's exactly the same thing as 0, 1, 0, but when we look at it, and we're going through our code, blah, 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 add relative force, we can see up. We don't have to get there and try to figure out 0, 1, 0. Which way is that? What does that mean?
Hold up. No object reference not set to an instance of an object. Line 26. Huh? Wait, why didn't mine work though?
Not just how fast we're going, but also what direction we're going in.
Oh, because I need rigid body.
Obviously, a vector 3 is going to have x, y, and z. If we're making a 2D game, it would be a vector 2, and we'd most likely just have x and y, depending upon which axes we're using. So 2D game, we just have the green one, which is y, and the red one, which is x. Unless we changed our game around, you can have it with the other axes, but convention says we would use x and y if it was a vector 2. You can check out our Unity 2D course for lots of other vector 2 type conversations. But in this course, we're talking all about 3D, therefore vector 3s. So if I was to pop in here, add relative force 1, 1.
What's the issue, bro? That's what I get for rushing. Okay, hold on.
Values, I should say. One for an X, one for a Y, and one for Z. The other thing I'll add about vectors is a vector is both direction and magnitude. So it's very different to position. Position is minus 6.75. That's our position in the world. That's X. But that doesn't show us where we're going or how fast we should get there. And if we want to move our object like that, we need to know it's heading upwards. You can see Y is going up when we do that. And it's heading at a particular velocity or a particular speed, if you will. And a vector allows us to capture both of those pieces of information, not just how fast we're going, but also what direction we're going in. And obviously a vector 3 is going to have x, y, and z. If we're making a 2D game, it would be a vector 2, and we'd most likely just have x and y, depending upon which axes we're using. So 2D game, we just have the green one, which is y, and the red one, which is x. Unless we changed our game around, you can have it with the other axes, but convention says we would use x and y if it was a vector 2. You can check out our Unity 2D course for lots of other vector 2 type conversations, but in this course we're talking all about 3D, therefore vector 3s. So if I was to pop in here, add relative force 1, 1, 1, and then semicolon, we're saying to the rigid body, add relative force relative to the rigid body's position and rotation of 1 on the x, 1 on the y, and 1 on the z. Let's save that, see if it actually works. Click on play, pop into game window, push on space, whoop, and it makes it fall over. Now what I'm going to do here is just have a little bit of a play around. We'll change this back, but for now I think the mass is too heavy. Mass of 1 is just a unit, doesn't mean anything. Is it 1 kilogram? Is it 1 something or other? We don't know, it's just a 1. I'm going to put this down to 0.2 for the moment, just so we can illustrate until we get some more variables in here to modify the force. I'm going to put it to 0.2, click on play. And now when I hold down space, vroom, it flies off. 1 unit for each frame that we're playing on the X, 1 unit on the Y, and 1 unit on the Z. That's why it went off in that particular angle. Side note, while I'm here, I'm just going to move my main camera a little bit. Double click on main.
What's going on? Why is it not working? No reference exception? How is that? How is this null? I'm referring to rigid body RB. That doesn't make sense, bro. What's wrong with my shit? There's nothing wrong with it. Rocket. Remove. I'm gonna do it again. Remove component. Rocket. Reference not set to an instance of an object. This is so stupid. There's
camera.
nothing wrong with
It's
my
not critical.
code.
We'll be doing more finessing later. I'm probably putting in a follow camera, I think, using the Cinemachine, but for now I'll just get a little bit more view of my world so I can make it go 0 on X.
Update process thrust, process rotation, input.get key, keep code dot space. I'm literally I have word for word exactly what it's. Yeah, I have exactly what it says. There's no reason for this error. I'm about to lose it, bro. I'm about to lose it. I hate this shit like this, man. Why? What's the issue? There's nothing wrong here. There's no null reference. It's defined right here, rigid body. Oh my gosh.
Zero on Z and 1 on Y, which is making it go straight up in the air. Let's click on play, just make sure that works. Okay, boop, 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 there we go, up in the air. We've got a rocket taking off, which is exactly what we want. Now, one of the interesting things within...
Hold on, I'm gonna just use Copilot. Fuck it. Movement dot process thrust assets scripts movement CS 26 error in this script. Give it my script. Take it away, co-pilot. Void start. Is that what I'm missing? Bro, is that the issue? RB? Oh, it's because I didn't initialize RB. Oh my god. Okay, see, that's why we use Copilot, so that we're not busting our heads for hours pointlessly. I definitely overlooked that. Okay. Good to know, guys. Alright, it should work now. Yep. Look at that. Look at that. Perfect.
Unity is we've got some shorthand ways of writing particular things. So 0, 1, 0. There's another way we can write this, which is vector3 dot up. Basically saying make it go up. And once again, you can see that we've got a little bit of information here, shorthand for writing vector3 0, 1, 0. It's exactly the same thing as 0, 1, 0, but when we look at it and we're going through our code, blah, 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 add relative force, we can see up. We don't have to get there and try to figure out 0, 1, 0. Which way is that? What does that mean? I mean, we can figure it out quick enough, but sometimes using this shorthand speeds things up, makes our code a little bit more readable. So just to prove the point here, we'll save that, jump back over into Unity and see that when we add vector3.up,
it doesn't have that option no more.
Space, it goes up exactly the same way as 0,
It doesn't
1,
give me that
0.
option. It doesn't give that option no more. Why did they take that out? Vector3.up. Okay, then import system numerics. Dog. Why would I have to specify that? Oh, you know what? Let me take out numerics. That's probably the class making it. There you go. Okay, let's see if that works.
1, 0. Which way is that? What does that mean? I mean, we could figure it out quick enough, but sometimes using this shorthand speeds things up, makes our code a little bit more readable. So just to prove the point here, we'll save that, jump back over into Unity and see that when we add vector3.up, click on play, space, it goes up exactly the same way as 0, 1, 0.
Okay.
There's more to add to this code, but I think that's good for this lecture. We've made our rocket fly.
Alright guys, we're so close.
This is a quick lecture to set up a tuning variable so we can tune how much thrust is applied to our rocket, as well as making our rocket frame rate independent. Let's start off with a challenge right from the start in this lecture. What I'd like to do is get you to add a variable into our code that allows us to tune how fast our rocket thrusts up in the air, and also add something to make our game frame rate independent. So if that makes sense to you, do those two things. Take it on now, pause the video, jump into that challenge. If you'd like a hint, then if you remember in the last section of the course, we talked about frame rate independence comes from using time.delta time. Time.delta time allows us to measure the amount of time that's elapsed from the previous frame, and to use that amount of time to multiply that amount of time to our program. How much relative force? Well, we're simply just adding 0, 1, 0, so that vector will make a very thrust, because we'll need to have a second sort of thrust, which will be rotation thrust when we get to rotation. And obviously we haven't created this variable yet, so let's jump right up to the very top of our class. Up above rigid body, we'll create a serialized field. So square brackets, serialized field. This will be of type float, because we want the ability to add decimal places to this, so it doesn't just have to be 1 or 2 or 3, it could be 1.7 for example. And then I'll call this main thrust. and initialize it, which means giving it a value now of, say, 100, just a complete guess here, I don't know what it's going to be. If we didn't initialize it, if we just had our variable like that, it would default to 0, and then we'd have to go and put something into our inspector. We're going to put it in the inspector anyway, but this way it just starts with something to give us a starting point 100, and because it's a float, it's good form to put f at the end of our number. Next, we need to make this frame rate independent, which is pretty easy. Once you get the knack of it, you just go and times it by time dot delta time. That way, every single frame, this number, whatever it ends up being, at the moment it's ending up being 010 times by 100, and then timesing all of that by a certain value, which is how long it took us from the last frame. So let's save, jump back over into Unity, see how this is looking now. We might need to change our mass. You know what, first of all, I'm going to change my mass straight back to 1. So I've got a nice round number for mass. There's no need to have it at a 0.2. Makes it a little bit less clear what's going on. So have our mass at 1. Clicking on our rocket, we should see that under our movement script, which I'll expand, main thrust of 100. Is that enough? I don't know. I'm going to click on play and hit space, and it's not really moving. Now, I'm not sure if we've talked about this yet. I don't think we have in detail, but while I'm in play mode, I can change the value of main thrust. Say I'll make this...
Is this something I missed?
So, and then timesing all of that by a certain value, which is how long it took us from the last frame. So let's save, jump back over into Unity, see... I don't know. I'm going to click on play and hit space. And while I'm in play mode, I can change the value of main thrust. Say I'll make this 1000 and see how that goes. Hit enter and then click back on my game window, hit space, and yeah, it's flying up in the air. 1000 seems pretty good actually. Okay. That's fantastic. Now, you probably know this already, but if we click out of play mode, our value on main thrust goes back to 100. That's a really cool mechanism within Unity. It means we can play around with our game and tune it and fiddle with it, not worry about the fact that we're making a mess of it, because when we get out of play mode, it goes back to where it was. Just means we need to remember those numbers if we make any changes that we like. So I remembered that it was 1000. Then when we click on play our game, fly up into the air a little bit, and then hop out of play mode, it's obviously still at 1000. So there we have it, just a quick lecture to get our rocket with the thrust movement the way we want it with those variables set up.
There we go.
I'll see you in the next lecture.
That's good, that's good. Nice. Hey, we're caught up to the last video. To my last time I did this.
In this lecture, we're going to make our rocket rotate clockwise and rotate anti-clockwise, or counterclockwise if you prefer, and fly around like a crazy rocket on the screen, and then turn a little bit into a tank. Okay, so let's jump in and get started. We've got our rocket set up so that it's going to thrust directly in its relative up position, and if we rotate it to the side, then it's going to thrust over that way. If we rotate it to the other side, it's going to thrust over that way. Whoops, I rotated on the wrong axis then. Just want to rotate on, what's this blue one? The blue one's the Z axis. So you can see we'll be changing the rotation within the object's transform by changing the Z value of the object. Okay, let's return that back to 0 from whence it came. Jump over into our script. And we're looking within process rotation for the place that we're going to be making changes. I'm just going to remove my debug information. That was handy to get things set up and make sure it's working properly. We don't need it now. What we do need to do in here is just jump straight into the rotate method. Yes. And we access that by starting off with transform dot, because it's the object's, this particular object's transform that we're accessing, dot rotate, which is a method that comes for free for us. Fantastic. Okay. Parentheses, within the parentheses, what sort of rotation we need to be doing. Well, once again, we're accessing a vector3, vector 3 dot, and we can put in here, you can see we've got the option right below here, forward. Vector 3 forward, if we mouse over that, is a shorthand way of writing 001. 001 corresponds with what? Corresponds with X, Y, and Z, so we're rotating on the Z axis. Now, of course, we could put in there
But if we're also
0, comma,
rotating,
0, comma 1, but we've talked about this already. It's cleaner for us to
If we're
add
also
vector3.forward. Well, I think it looks cleaner anyway. Okay, so we've got vector.3forward. Let's save that. Just make sure that we've got something that's working before we get too excited, as always. Okay, we've got an error because Rick forgot to put in a semicolon. Voted the #1 C# error of all time is forgetting to put a semicolon. I know that's happened to many folks out there. Okay, space thrust is working. Can we rotate right? We can't. We can rotate left. It's good to know. Let's have a look there. And yes, I was hitting A, so that's correct. Vector3 forward is rotating as we wanted because that was making us go to the left when I pushed on the A key. Okay, I've got a challenge for you. Make your rocket rotate to the right when you push the D key. Nice, easy challenge. So pause the video and do that
why
now.
would forward be okay? Whatever.
Okay, I shouldn't say nice, easy challenge because there is one tricky bit to it. I'm going to copy my transform.rotate, etc., paste that in. The tricky bit here is if I just leave it like that, both of the keys are going to rotate in that anti-clockwise or counterclockwise direction. But what I can do is pop in a negative in front of this. So we're adding a negative forward. So instead of adding a +1, we're adding a negative 1. So save.
Okay, I don't know.
Check this works once again before we celebrate and have a party, invite our neighbors over. Check what I did. I made it rotate left and right. Yes, okay, we will have a party. Send out the invites. Excellent. So we've got that working as we wanted to. So there's two more steps I'd like to do on this, and we've already got ourselves ready for them and practiced them in a standalone video. The challenge I'm going to give you is to add a tuning variable so that we can rotate based upon a particular value that we set, and also so that we are frame rate independent. Okay, so take on that challenge, add a variable.
Add a variable so we can tune the rotate speed.
And make it frame rate independent.
Serialized field float rotate speed.
I'm going to start by adding my variable up the top just to show you we can do these things in many different orders. Serialized field.
Yep.
Once again, I'll make this a float, and I will call this rotation thrust. Rotation thrust or rotate thrust? Yeah, rotation thrust, I think. And we'll start that off at, I don't know, we'll make it 1, I think. I haven't played around with this yet.
Okay.
Scroll back down. Now we can multiply our vector3.forward, which is 0, 0, 1. Multiply that by rotation thrust. Our clever Visual Studio autocomplete knows what I'm after. And then we times it by time.delta time. Copy those 2 bits I've just added, the rotation thrust and time.delta time, give us a space, and pop that in down below as well. Save this, and just a note, I'm working on the assumption that I want to rotate consistent speed to the left and to the right. If you wanted to have a different left thrust and right thrust, then you would have 2 different variables in here. But for now, we need just one member variable, which we've got up the top here. Member variable means we can access it in any of our methods throughout this class. We can access rotation thrust. So jump back over into Unity, have a look at Rocket, wait till it compiles. That's too little. Rotation thrust will make it say 2, so 100. And click on play. Who knows if this is going to be right? It's not, because we're not rotating at all. Let's do a little bit of playing around while we're in here. Just throw it up to 200. Okay, it's not going to like it since I've smashed into the ground. So we'll make it 100.
Yo, what the fuck? Did y'all see that? Oh, man.
And that's all right for now. There's a lot more tuning to do, so don't worry about having it perfect just yet. But if this is kind of a bit fun and a bit silly to play, then you know what? We've got a game coming along, which is very exciting. Okay, now the last thing I'll do in this video is it's bad practice to have code which is doubled up. This line of code is pretty much exactly the same as that line of code with just a negative symbol in the place. You could leave it like this, not a problem. No one's going to perish if this happens. But the problem comes if we want to change something in here, we also have to change it down in here as well. And while you've only got 2, it's not too bad. But if we're using this 3 times or 4 times, or in many different places, or we forgot to do it, it can become a bit of a pain. So while there's 2, it's not too bad. You could leave it. But let's just do a little bit of practice. Making our code more readable and more expandable, and in doing that I'm going to show you a technique to use parameters to set up an overload in your method. Okay, so first of all what we need to say is this spot just here, this line of transform.rotate, etc., that whole thing can be a method that we pop down below. And a shortcut for doing this is I can hit Control, or I believe it'd be Command, but Control period, or Control full stop if you're from Australia like me, and that will bring up a little menu that says Extract Method. Click on Extract Method, and you can see in the place of our line it now says New Method, and down below we have a method that's been created called New Method. One thing that might look a little bit odd is it's added the keyword of private. It's a little bit unnecessary to add private because it's private unless you go and add the keyword public. So some folks will add private for all of their methods that are private. So in here we could add private. If I can spell private, so we can add private throughout. I tend not to do that. I just leave it as a nothing if it's private, and I would write a keyword if it was public. Now we've talked a little bit about public,
Void
private.
is just default,
Public against
Void
a
is
method would
set
mean
to
that
default. There's
other
default, public,
classes
private.
can call this method, and we'll do some of that later on. For now, we don't need to do that, but that's just what public means in this instance. If I remove public, or if we leave the keyword there of private, it means only this class, this movement class, only the things in here can access, can call, can change, can modify anything to do with our new method that we've just created. Now, we don't want to leave it called new method, so I'm going to double click, hit F2, and name it apply rotation. Because that's what we're doing when we want to call this method. Apply rotation when we hit A. And we will also, instead of adding this line just here, we'll remove that so we're not doubling up. And we will once again call apply rotation when we hit the D key. Now, if you're a clever sausage, you can see a problem just here. What has happened to our negative sign? Where are we going to put that? We can't really put negative apply rotation. That doesn't make sense, and Unity's not happy about that, or Visual Studio's not happy about that. So this is where we can set up that when we call this method, it says, I need you to tell me whether this is positive or this is negative, and I'm going to apply that somewhere in my rotation. So in our method that we've created, we're going to stipulate, so we're going to say, you must give me an extra bit of information when you call me. So we need to give it a type and a variable name. The type will be a float. We want it to say, give me a number, and that number can be a decimal place number, and we'll call this rotation this frame, because this has been called each frame. So how much are we going to rotate this frame is going to be the transform.rotate. Instead of rotation thrust in here, I'm going to use whatever value is provided when this method is called. So we'll call it rotation this frame. We won't call it that. We'll use that variable. This is the variable that's being passed in that we can now use in this spot. And we're going to be passing in either a positive or a negative, depending upon whether we want to rotate to the clockwise or anti-clockwise. The place we now need to pass this in is our apply rotation where we're calling it. And you can see the red squiggly line. It's saying we are expecting some more information in here. If you've been following along, hopefully you'll know the last step to this. What do you think is the argument that we can pass in for key code A and the argument we can pass in for key code D? Just take a moment to think about that. See if you can figure out the logic here and add in what you think is the right answer.
The get key or
well,
whatever,
we've already
right?
got ourselves a variable which is rotation thrust that we're quite happy with. So let's use rotation thrust in key code A. Rotation thrust. That will have a certain value. At the moment we've initialized it 1, but we've changed it in our inspector to 100, I believe. So it's going to be 100. And then under our keycode.d, where we want to rotate the other direction, we're simply going to change our value from positive to negative. So negative rotation
I get
thrust.
it now. I get it.
Okay, so now our code is much cleaner, very readable, and we can easily be passing in whether it's in the positive Z or the negative Z based upon whether we hit A or D on the keyboard. So once again,
wait, hold on. So we use apply rotation.
Make sure that everything is
get
working
key.
hunky-dory. Click on play.
Okay.
In the air, to the right and to the left. Yes, it is. Whirr, zoom off the screen. Okay, that's cool. That's allowed us to set up our own parameters and to pass them into our rotation.
Done.
So there we have it. We're rotating,
guys,
we're moving. Still a lot of finessing to do, but we're making, I believe, so it's going to be 100. And then under our keycode.d, where we want to rotate the other direction, we're simply going to change our value from positive to negative. So negative rotation.
I've just been so comfortable in my job not thinking.
Okay, so now our code is much cleaner.
Alright, hold up. Okay. So apply rotation takes in the rotation this frame as the argument. The argument is what it's processing based on what we press on the keyboard, right? So we're gonna use the process rotation in the update. That's what calls it frame by frame. Okay, those are the two methods that trigger it. So okay, so A and D trigger process rotation, and then the space trigger process thrust. Oh, you guys can't even see my thing. I'll just show it. I'll pull it up real quick. Properties. Let me see. Where is it? Why can't? Okay, there it is. Okay. So look, guys. Here's what I'm doing. I'm gonna just because I'm looking over it. You guys could follow along. Okay. So rotation this frame is pretty much what we're telling. It's what the function takes in to process the functionality that we explained up here, right? So it's based on if we press A or D, since we're using this, like this is inside of our process rotation method. And the update is what makes it so that like by frame, like as we play, the control is triggered. So process rotation is only triggered if we press on A or D. And if we do A, we take in our rotation thrust, 1F. Well, we made it 100 in the game, but right here's 1F. And that's what we're passing into our apply rotation. So it would rotate to the left fine. And then we do negative rotation if it's triggered by the D, and does the opposite. Okay, I just got to break it down so like I know what I'm doing. I don't want to just follow along and like I don't understand what the hell he's doing because then I'm confused the next day. But all right, so let's go over it one time. Let me just play it one more time because I gotta wake up early tomorrow, so I'm gonna go ahead and call it here. But it's so good that I caught up to where I was last year when I stopped doing this, and from here on forward, it's all new stuff. So that's super exciting. Tomorrow I'm actually gonna try to no life it and get past like 75%, if not the whole thing. I've just been a little occupied, but all right, enough yapping. Let me put this away, and let's see. Let's see how it feels. Let's see how it feels. All right, we're flying. Nice, nice. That feels nice. Oh, you could already imagine the obstacles I'm gonna add. Yes. Nice, nice, nice. Oh, 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 I don't like that it does. Sometimes it does that. Sometimes it makes it like, sometimes touching the platform and shit, it makes it turn all weird and stuff. Like, why is it doing that? It's so weird. Hopefully he teaches us something to fix that, because I don't like that it does that. We have Copilot for that worst case scenario, right? Like, why does it do that? So weird. It's so weird how it does that. All right, guys, that was it. That was a good session. We got pretty far. If you followed along, shout out you. Even though I know you guys probably didn't. Sorry, I'm not butthurt. Hmm. Yeah, we'll work on that. All right, guys, that was a good extension. We got through like one fourth of it, I think. A little less than one fourth of it. But hey, that'll do for now. I got to get ready for bed and stuff. So, shout out whoever watched, whoever stuck through it. Make sure to follow me not only on the one, whatever you're on right now. I'm Kevin Condori across all platforms, YouTube, X slash Twitter, Twitch, and Kick. So be sure to follow me on there. I haven't rebranded my Instagram yet. It's still on like music videos and stuff. But if you guys want to follow me on there too, underscore Kevin Polo. I actually have a following on there, so I won't look like a complete scrub. It's a small following, but it's better than like 50 to 100, right? All right, guys, I appreciate you.